Again, I just want to remind you of what we've all kind of seen here. Oh, maybe I should put the microphone in so people can hear me. Again, I just want to remind you of what we've all done in this kind of quick unit. Again, the plan that I had created is we were going to start on Earth, going to learn about the Earth and the way it's oriented in space, how it moves around, move our way out to the satellites and to the moon, and then ultimately discuss the planets, and then eventually out to a star, talk about the way stars live in terms of burning hydrogen fuel, turning it into helium, and then how they die, what happens after their fuel runs out. So we talked about the life cycle of stars. And then yesterday's lesson, we went out to the largest objects in our universe, talking about galaxies, very massive groups of stars, and then ultimately the universe itself, being this kind of weird four-dimensional ball that we kind of live within. Again, as you get further away and further out, again, these are theories, these are ideas based on the physics that we know, all right, applied to what must be happening out there. Okay, so now we're going to return back home, right? It's been an awesome little trip out to the stars, and now we're returning to get ourselves, our feet back on the ground, and looking up at the sky and describing what we see in the sky. So that's what our last little lesson here is. What does all of this stuff look like from our point of view here on Earth? Click. So the first thing I want to talk about is something that that we describe as the celestial sphere. I'll let you write it. We'll talk about it, and then I'll show you a picture, and then on the board I will show you how we would draw a sketch of this. What's so funny back there? Do I have spelling mistakes? Be nice. Shapers. Mean kids. I'm glad it's almost over.
I'm going to get another round of things.
Oh, man. Hopefully they're nicer than you guys. Yes? All right. So, and this is almost historically speaking, even though we can go outside and look at the sky, historically speaking, before early astronomers looking out at the sky, before they realized that there were, what these stars were and how they behaved, right, it's been a common thing or a common practice for human beings to go outside at night and look up at the sky, all right? There's lots of exciting stuff to see, all right? So I'm not talking about meteors or things like that, but I'm just talking about the stars themselves. And early astronomers, early scientists, one of the first things that they really observed and made note of was the position of those stars and how those stars' position changed over one nighttime, right? Because I don't know if you notice it or realize it, but as the night goes along, that group of stars seems to rotate with respect to us. Right now, we're the ones that are rotating. It's the Earth that's turning in the field of stars, and that's why we see the stars move across the sky. It's the same reason we see the sun come up and the sun go down, and the moon go up and the moon go down, because we're on a rotating field of view, we're on a rotating point of view. But from our point of view, we can't feel the motion of the Earth, so we see the stars move around a particular point, and that thing that we see, we call the celestial sphere. Early astronomers, and I'm talking even before Greek, philosophers, before then, early astronomers, some believed that there was actually like a crystal sphere that our Earth was within. So we lived on this thing that then was embedded inside this big sphere that had either little points of light on the sphere. I've even read about them imagining that it was almost like a blanket with little holes in it that allowed light through, but some kind of sphere that we live in that then goes around and allows those stars to move from our point of view. Many early astronomers believed that Earth was the center of the universe, again, because we have this viewpoint on a rotating sphere that's moving around the sun. But if you don't take those motions into account, it looks as if though we're stationary and everything else is moving around us. All right? I then talked a little bit about, when we talked about the solar system, how a guy by the name of Copernicus said, well, what if the sun was the center? That's going to change everything else. And then Galileo did it again. And then in the end, we with the help of Kepler, we know that we're on this moving point of view, the Earth going in orbit. But from our point of view on the Earth, when we look up at the sky, we see what we call the celestial sphere. Again, I did some cutting and pasting out of the book or offline. And so here's our Earth with then this sphere. These dots, which represent the stars, they're not in the sphere, they're on the sphere. All right? They're on this big, bubble, this big sphere that we then here in North America look up and we see this group of stars. Okay? So if I'm going to get you to draw this, and I'd like you to, right, I'm again going to draw the Earth, right, and you can make it whatever size that you've got room there on. And I'm going to put the equator this way. All right? I'm going to have the north here, so I'm going to put an N here and an S here so that you can see it. And then I'm simply going to draw a larger circle around that. All right? And that was okay until I got to this side, and then it failed miserably. I'm going to draw a larger circle around it. Again, I'm going to have this point right to here, right there to that spot. And that point right there is what we call the North Star. All right? And because we're in the northern hemisphere, we can see that North Star all night long. It's off to the north. For those of you who aren't sure where the north is, I put a big N on that wall over there, and a big E over here, and then a big S up here, and a big W over there, so we know where we're heading. So at night, right, it's over there, it's underneath my thermometer. At night, that North Star is out there towards the north, okay? It's called Polaris. Let's put it on our picture. Polaris. The reason it's called Polaris is because it extends out from the pole, the North Pole. All right? I've never heard of any such South Star. There must not be a star in the position where you would extend the South Pole's axis. Okay? All right? And so because we live over here, right, on the northern hemisphere, we can only see that half of the celestial sphere, right? And we can actually only see it if this is us right here, and you don't need to necessarily draw this because I don't know how this is going to look, but you could only see kind of that half of the sphere. You can actually see the whole half. You can actually almost see that 180 degrees up there. So we have to look that way to see our North Star, and so we look out that way and we're seeing that line extending out. Okay? All right? Okay. So this celestial sphere, it's not a real thing. It's just what we imagine the stars kind of being attached to. All right? When my son was just a kid, was a baby, I got a bunch of those glowing stars. How many people have the glowing stars in their bedroom? That's kind of fun. And I actually, being the geek that I am, in the direction of where those constellations are supposed to be at a particular type of year, I put those stars in those positions. Now he's a biologist. I don't know what went wrong. I tried to steer him as much to chemistry and physics as possible, but I failed. Now he catches insects. But that's okay. All right. So how do we locate things in the sky? We need two numbers. Something called the azimuth. I've seen it called the azimuthal as well, A-L on the end, but our textbooks just call it the azimuth. It is an angle between 0 and 360 degrees. Is that the spelling problem? What's wrong with it? Is it? I'm going to check my book because that's one I thought I had to get right. All right. That one I want to check. Is it an S? Why am I doing? Well, now I don't know. Let me check. You know what? I'm thinking of Zenith. Beyond the solar system, satellites, stars. Azimuth. A-Z-I-M-U-T-H. Oh. Really? Why did I do that? Because I know how to spell that. Oh, I thought you were talking about that Z. Okay, well, you are allowed to make fun of me for that one. Look at you. That is my Grinch. Spelling is my Grinch.
I can't spell either.
Oh, goodness. Well, then I feel your pain. All right, let us continue. Now that we've solved the controversy of the Z, we've got it taken care of. Okay, let's get back to it. What are you going to tell me about now? Where? Just means what that is. What if I just want to locate one object in the sky? I'm going to continue. All right. So, when we locate something in the sky, we need two numbers. So let's say that you get yourselves a telescope and you want to use that telescope to locate a particular object. With the help of an app or perhaps a computer program, very simply, you can simply ask it to tell you what that location is. It'll give you two numbers. It'll give you the azimuth, which is a number between 0 and 360 degrees, starting from north, right? So if you've got a compass and you know where north is, and depending on what they tell you what that azimuth is, then you can easily locate that angle using your compass, all right? Most phones, you can get a compass app, and that's because in our phones, there are magnetic field sensors that have the ability to sense the magnetic field of the Earth, all right? And just like compasses will point to magnetic north, our phones will do the same, all right? And so then starting from that, you would then just turn with east being, well, how many degrees would that be if we're starting from north, yep, 90 degrees. I was going to fill that in. You go ahead, you can fill that in if you've got a pencil. Fill in my 90 degrees. My south, what would it be? How many degrees azimuth would that be? Yep, 180 degrees. I can't use chalk. I can use my Sharpie marker. So 180 degrees. And the west will be, yep, 270. Yeah, Jamie, if you could fill in my blank there for 270 degrees, that would be great. So depending on what it's telling you the azimuth is, you would have your compass or your phone, and if it said something like 105 degrees, you would be, you know, kind of aiming in that direction there. Okay, everybody kind of catching the azimuth? So the azimuth is the first number, which tells you which way to point, all right? The second number is the altitude. That's simply from straight out, the horizon, to 90 degrees, which we call the zenith, all right? So the zenith is always straight above your head, okay? There are multiple ways in which you can do that if you don't have a phone with you. Again, the phone will do it. Too bad it isn't on Apple. I didn't even check it because I always use it on my Android phone, but it'll point you right in the direction, and it'll tell you how high you've raised that, and that uses a gravitational field sensor. So it knows which way is down because it's got a little kind of gravity sensor in your phone, and therefore if you point it up, it knows how many degrees you've lifted it up. So the phones work really good for that. If you don't have a phone, there are other ways. This little piece of apparatus that I found from another piece of lab equipment simply takes a protractor with a little heavy weight. I believe this is like a fishing weight, right? It's got the string tied to the center of the protractor, and I've seen people make these, you know, just out of a regular protractor, tape a straw to the top, tape a little fishing, you know, thing to it, and if you then had this outside, you tape that straw to the top, and you want to locate. You know, you want to locate what that angle is. Let's say it's 45. You point it at that. You get the right azimuth. You look through the straw, and you should be able to, you know, locate that particular thing. Or if you wanted to tell someone where it is, the same thing. You use your protractor, right? Not your protractor, your compass to get your azimuth, and then you could use this type of thing. And as you look up, you could get your friend to read what the angle is, and you'd have the altitude. Okay, all right. So again, an angle of high up. All right. We don't know how far away these stars are. That's something that we've already talked about. But when we're looking at the celestial sphere, we don't care how far away they are. We just want to locate the stars in the sky. Again, the term zenith doesn't have anything to do with measurement, but it's just the term that we use to describe straight up the zenith. All right? Okay. At this point, I was going to show you the app, but that's kind of failing. No need to write anything down here. Again, these are pictures that I've found in various places. This comes out of the textbook. And again, if that's north, right, we're going clockwise through east, through west to get the azimuth, and then we're using some kind of angle measuring device to look up in order to get the altitude. The textbook has questions on this. I think this is just really more of general knowledge. I'm not going to make you know this for a test, but we can kind of estimate degrees, right, by taking the size of various hand objects held at arm's length. All right, we got to hold it at arm's length. And again, this isn't standard because, like, I've got fat thumbs and fat fingers and probably a fat wide fist, and my arm's longer than your arms. But this is just kind of a general thing that, you know, just as an estimation, if you need to move over by a degree, your finger reached out at arm's length, then kind of spreads out by about a degree. So if you move over by 1 finger width, you're moving over by a degree. Now you got to kind of close one eye, right, so you can see what that looks like out there. But you can't do it here, right, because if it's really close to your face, now it's a much larger angle because it's really close. So you got to have it at kind of standard distance. And they say that your fist is about 10 degrees, and if you open your hand, the span across from the thumb to your pinky is about 20 degrees. So if you were kind of wanting to kind of take a look, you could use that to get, say, 30 degrees or 40 degrees, et cetera, et cetera. But again, now that we have phones, goodness gracious, you could just point at the darn thing. This again is another picture that's stating the same thing. All right, so here we've got the celestial sphere. Here's the North Pole, and where we're standing on the Earth, right, you'd then have, this is our local horizon, and then there's the zenith straight up ahead. They do have a term for the one below, nadir. I don't even know what that stands for, but that would be straight down, you know, if you could look through the Earth down to the bottom part of, or the opposite of the zenith. Okay, let's define a special term called the ecliptic. So we've got some terms that we're collecting here. Horizon, right? That's what we can see, right, all the way along there. The zenith, which is straight up, it's 90 degrees from the horizon, is the zenith. And you can see we're kind of talking about circles. Again, the horizon is that flat circle that we can see straight out. The zenith is straight up, it's a point. And now we want to talk about something called the ecliptic. Again, astronomers many years ago, they would be mapping all of the locations of the important things, such as planets, and the sun, and the moon. And you may not realize it, but the planets and the sun and the moon across our celestial sphere always travel kind of together on this common line. Again, it's a circle, like the horizon, but it's the circle that the sun follows through the sky during a day. All right? And what we're looking at, that circle that the sun is following through the sky, is the line or the plane in which all the planets are on. That's what we're seeing. So that means the planets also will follow that circle through the sky. We call that the ecliptic. Because we're in the northern hemisphere, right, that ecliptic is towards the south. And I'm hoping we know that the sun, do I have my directions backwards? No. Right. The sun rises in the east. Yeah, the sun rises in the east. Well, I don't know why I briefly thought that, because everyone's questioning my spelling and I'm questioning everything I'm saying today. So anyway, let me get back on track. As we know, which I just questioned moments ago, the sun rises in the east, right, comes up that way, travels along the sky for a while, and then sets in the west, right? And that path that it follows is what we call the ecliptic, all right? And if you were to use your apps or use whatever to locate the planets, you would see that those planets also follow that path as they also move around the sun in their orbit. So that's a very kind of common traffic place for things to move in the sky, all right? Okay? And that's because of the sun's rotation the Earth's rotation that we see that sun rise in the east and set in the west, all right? And that's called the ecliptic. Let's take a look at a picture of an ecliptic. You can write that down. And don't worry about writing the winter part. Just write down the fact that in the northern hemisphere, the ecliptic is to the south. And at this point, I'm disappointed because I wanted us to use our app to locate some stuff. Maybe we'll do it at the end of the class. We'll see if I can find another, maybe an equivalent app in the Apple Store, and see if we can use it. But at this point, I would have you guys, I would turn off all the lights and show you the app and show you the ecliptic the way it kind of looks right now. I can show it to you on a simulation that I have online, and that's where this simulation came from. You'll notice I'm pointing the Earth, this is the ground, in a southerly direction, and this then shows where the ecliptic is. and I even advanced the time to January 25th, 2020, so I jumped ahead a little bit, but that's where the ecliptic will be at 1 o'clock in the afternoon on January the 25th. And can we see where the sun is in there? Neptune, I think maybe the sun's in that location, and you can see there's lots of planets all along that line, okay? The way the simulation works is it makes this a curved surface. The way we actually see it is that the ground is obviously flat, right? And the ecliptic bulges up a little bit. So this gets stretched down, and then that bulges up. And then that gets us our ecliptic from east back down to west. Sun rising over here, sun setting over there. Okay, and I'm going to show you that simulation in a moment. In the winter, in the summer, you can see the ecliptic is much higher because, again, we're on the other side of the sun, and we have a little more angle to the way that the sun goes. So again, this is curved, but if I bend this down, this is even going to go higher in the sky. And here I've picked July 25th, 2020. All right, so that's what this simulation predicts. And you can see there's the sun right there, high in the sky. I picked about, again, 1:30 in the middle of the day. And in this case, you can see that the sun goes very high in the sky. The ecliptic is very high during the summer, and that's why we have lots of hours of sunlight, because that sun is in a very long path. The ecliptic is very high off of the horizon, and the sun stays nice and high. I don't know if you noticed these days, we're kind of getting longer days. We're past that shortest day of the year, but the sun does not get very high in the sky this time of year just because of our orientation with respect to the ecliptic, that line that sun travels past, all right? Again, I could try to show it to you on my phone, show you what the ecliptic looks like. And I'm going to run my app, and you're not going to hardly be able to see anything. You'll notice the way the app functions, right? I don't know if you can see it, but you can see a lot of little dots on there, all right? If you've got it and you've got it running, that's great. You can see a lot of little dots on there, and you can see as I'm looking around, it kind of moves with me. It's like an augmented reality. You know what I'm talking about, where it's projected what we're actually seeing in behind it, and you can see that line, that green line right there, and that green line is the horizon right there that says south, okay? So now if I look up into the sky a little bit there's a line that's cutting across, I don't know how many degrees up, right? I've got here the azimuth and the altitude. If I look up to the top of that right now, there's the sun right now outside, if we were to look at it, and if I put it in the middle, its altitude is 18 degrees up, and I'm looking at about 180 degrees, so I'm looking just past south. And that wasn't the highest part in the sky. The highest part in the sky was right about there earlier on in the day, but you can see how there's my horizon, and there's my ecliptic, right, where the sun would travel on. I could look this way, and I can look towards the ground, and right there, that's where in the sky the sun will cross, into setting this evening, right out about that direction. It's going to be an azimuth of 240 degrees. That's where the sun will set tonight, all right? Okay? So that's how this app kind of works. It works pretty good. Up in the corner, it has here altitude and azimuth. So as you point it to various things in the sky, we can then find them. It's kind of neat. You'll notice it's very dark, and it's got very dark colors on it, and that's because we want to use an app like this at night when you're using a telescope, and you don't want a bright screen making your pupils go tiny, so then you can't see the stars anymore. So it uses dark colors in order to do that. Okay, so that is the ecliptic. Again, I just want to show you something else here. I want to fire this up here. This, again, is this app that I've been showing you. It's kind of a fun one. I think it's a good one. This is the one, remember, it says, hey, take a look at the lunar eclipse. That was 4 days ago. If you go to Planetarium, that's then going to generate this map. And this map is the map that I've been using to make those particular things. There you can see south. I can drag this with my mouse so that I'm looking, I'm looking north, but this time I'm pointing towards the south, so that's this sky. You'll see that I've got a time. Take a look here, folks. Hey, take a look here, folks. If it's astronomy, that's great. Oh, that's excellent. You got it to run. Good. You have to pick a location on the map to tell you where Petrolia is. That's a hard thing to do. You'd have to know the latitude and longitude. That's okay. Excellent. I'm sorry. That's good. That's a good thing what you're doing. Okay. So you can see here, south, and we've got a bunch of different constellations, which I haven't talked about yet. But I can drag that around, and if I scroll to the bottom and I want to see the ecliptic, I can click on that. Let's get rid of daylight. Let's make it just dark so it's like we're out at night. And I can do all kinds of interesting things. I could get rid of the planets. Deep sky means we're talking about galaxies, the things that are way out there. Stars, I could shut off the stars if I wanted to. I could get rid of the constellation names. I could even get rid of the stick figures, okay? I'll tell you right now, you've got a little assignment, not an assignment, but a practice sheet where we're going to find some constellations, just checking the time. And on the test, and perhaps on the exam, you might have to locate these constellations that I'm teaching you about today. Yep. Awesome. That's a similar thing to this. It might not be as much detail as this. So if I can bring this back up, you'll see there's the ecliptic with all those planets moving along there. There should be a sun in there somewhere. I'm suspecting the sun's in there somewhere, and that's what we're looking at as we move along there. So that's kind of a neat thing. Let's talk a little bit about constellations then. I'm going back here. Constellations. So you can write that down. We're at the next point in our little lesson. Yeah, the SkyEye app needs to know where you are on the surface of the Earth so that it can then plot everything in the right places. I don't like that little map. You could touch on the map, but that's the way I did it, and it's really a pain because who knows whether you got Petrolia or whether you've got Toronto or whether you've got, you know, Northern Ontario because it's such a tiny map. The ideal thing would be maybe to Google the longitude and latitude for Petrolia and then type in the longitude and latitude. Then it'll have your exact location. Perfect. All right? If you've fired up the app, you might notice it says, if you get into it, it says abnormal magnetic fields. And that's because we're in a building and there's metal in the walls from various piping and things. So that's going to change the magnetic field rather than if we were outside. So it's designed to work outside, ideally, okay? Yeah, it says strange magnetic fields. And therefore, it means it really doesn't know exactly where north is. So don't take the data perfectly. If we were outside, away from a big building that has lots of electrical wiring and all that type of stuff, then you wouldn't have that abnormal magnetic field warning, and it would work just fine. Okay, so constellations, this is something that you know all about. You know that if you look up in the sky, you can see shapes that are interesting and fun and that have certain names to them, perhaps named after Greek heroes or Greek gods, some named by indigenous peoples, things like the Big Bear, Ursa Major, which is the Big Dipper, or the Little Bear, Ursa Minor, which is the Little Dipper, et cetera, et cetera. And I'm going to just show you how to find a handful of them, not even a handful, not even 5, just a few of them, just so that I've shown you how to locate these, and maybe some interesting stars that we've already talked about. Okay, so a group of stars that observe from the Earth, typically named after animals, heroes, mythical monsters, etc., etc. Okay, so at this point, don't write this down. Don't write it down, because at this point, if we're going to go to Google Classroom, and you can leave your note. You can even put see Google Classroom for today's date. because I've given you a Google Doc, which I'm hoping that you will then write on with your finger or whatever to then go through the motions of locating these particular constellations, okay? Because for the sake of testing, because I've taught it, I will make you find 1, 2 of these particular constellations, maybe 1 or 2 of these particular stars, etc., etc. So you have to be able to know how to do these. So again, like I said, go to Google Classroom, and I'll show you what it looks like. Go to Google Class, not there. Yeah, it is there actually. Go to Google Classroom. I want you to open up, I got to go to the right class. I want you to open up this document, which should be in your work. You should have your own copy of it. You will see the instructions, all right? You will see the instructions, and then you will see this map, okay? And I'm going to help you find those stars and use this to find other stars. Everybody kind of catching what I'm talking about? So open that particular thing up. If you're going to then use the pen thing, come on up and grab a stylus if you want one. Yep. I got to always think about this. I believe longitude is the north one and latitude is the east one. Okay. The east-west one. Yeah. Okay. Yep.
I found one on Apple,
yep.
But it's not like you move it around.
Right. You move around with your hands. That's pretty cool too. You'd put the dates in and then you just move it. I don't know what you're speaking. And what does it do?
It's a planet.
A planet?
It's your planet or something.
Really? How about that?
We learned about it.
Okay. Did I talk? Was it in our notes? Oh, nice job. Good. I have no idea. That one I didn't know. Yes. Yep. Yep. Awesome. There's lots of these things out there. That's great. I'm not going to have you use something like that on a test. I'm simply telling you about their existence. So if you're outside and, it's dark out and you want to, take a look at various things, you've got access to all kinds of stuff. So I'm going to go back to my particular PowerPoint because I'm going to write on it. Do you guys have this document open, ready to kind of join in? Okay, so I'm going to go back to the PowerPoint, and I'm going to go through this. Okay, the Big Dipper. Do we all know how to find the Big Dipper? No? That's exciting. That's one of the staples of the sky, especially the north sky, all right? Because we're in the northern hemisphere, there are a handful of constellations that rotate around the North Star in our celestial sphere that always stay above the horizon because we are looking at kind of the top of the celestial sphere. The Big Dipper is one of them, the Little Dipper is another one, and Cassiopeia is the third one. Those are what I'm going to teach you about for the northern sky constellations, okay? So the Big Dipper is just kind of a slang term for Ursa Major. It consists of 7 stars, and it looks like a dipper, like a soup ladle. Now, you'll notice I've got January 12th. I tried to pick today's date. Did I get it right? Is today the 12th? 14th. I'm 2 days off. The Big Dipper is right there. And it has these bright stars, 1, 2, 3 in the handle, and then 1, 2, 3, 4 in the dipper. Everybody see it? I'm now going to draw it on. I will use blue in this case. You can draw it on as well. It makes no difference. There, 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 there. All right? And if you want to close the dipper up, you can. But then it's not much of a dipper. It doesn't dip very well. You see what I mean? A soup ladle? This is the Big Dipper. Big Dipper. Or Ursa Major. Now, the Ursa Major stands for the Big Bear. And there are more stars that they count for the Big Bear. Because this is supposed to be the body of the bear, and that's supposed to be the head of the bear, and this is the tail of the bear. and I believe a couple of them going out this way are the legs of the bear. So the bear part of it is a little complex. If you turn on and turn off the constellations on your app or whatever, it may show you the entire bear. I'm hoping we can locate the Big Dipper. Looks like a dipper made of 7 in the north sky, all right? And it depends on what time of day or what time of night you look at it. This morning I was up pretty early, and I go outside, I took a look. The Big Dipper was way up to the north, or way up to close to the zenith, upside down, right? But during the evening, it would be on the opposite side, because 12 hours, right? It goes around in 24 hours. In the evening, it would have been down at the bottom, all right? Okay? All right. So that's the Big Dipper. Let's now find the Little Dipper. Now, the Little Dipper is harder to find. The first thing we need to find is the North Star. The North Star is easy. The instructions are there, but I'm just going to tell you what you do. You take the end of the dipper, all right, and you extend that with your eyes. Just follow it along as if it's a line, and boom, you get to there. So if you take the end of the Big Dipper and you just follow that along, you will get to the North Star. Right there is Polaris, all right? Polaris, all right? That's the North Star. What's that? I have no idea. Spell it correctly. Don't spell it like me. All right? Polaris is the North Star. Okay? All right? So, in this case, like I said, this morning, the dipper was down like that, and if I followed the end of the dipper, I would get to the North Star. Pretty well pointing straight north. It's about 45 degrees off of the horizon. It's got an altitude of about 45 degrees. Okay. Now, the Little Dipper, this is the end of the Little Dipper. All right? The Little Dipper turns the handle the other way and then has kind of like the scoop upside down. It's got a backward bend to its handle. All right? I've seen many people close this up in order to see the entire thing. I've seen many people close that up. All right? So the end of the handle of the Little Dipper is Polaris, the North Star. And so the Little Dipper, this is the Little Dipper. Oh, and it doesn't matter. Little Dipper, all right, is part of that thing there, okay? Now I'm going to struggle to find Cassiopeia. Uh-oh, I'm going to be in trouble. The way you find Cassiopeia, and Cassiopeia, I believe, is named after an Egyptian princess, and I'm not sure how those particular dots make up what you could consider an Egyptian princess. But we're looking for a W or an M, depending on which way it is in the sky. And it's essentially on the opposite side of the Big Dipper. And so it's in this area here, and I'm not sure which stars it's going to be. I think it's there. There it is there. It's not way over here. It is this 3 right here. There it is. Or sorry, it's 5. 1, 2, 3, 4, 5. Yeah, that's it right there for sure. So what does it say in the instructions? And we're getting the instructions right out of the textbook. The text would say, continue your line from the Big Dipper past Polaris. You will reach an M or a W, 5 stars. I guess it's not straight across because it's right there, but that's it right there. That, and that. And I have no idea why that's supposed to be an Egyptian princess. All right? And I'm not even going to try to write Cassiopeia because you guys are being mean to me spelling today, so put it on there yourselves. Who's going to help me? Someone going to help me? What is it?
I don't know how to actually spell it.
Oh, what do we got? Cassiopeia. Cassiopeia. those are the three things. I guess there's four things out there that I'm going to expect you to know about. Something that they told me in my astronomy course, that course that I have the big fat book on. This has nothing to do with it. You don't even have to write it down. But we were told that that star right there, if you look at it in a telescope, are two stars that are really close together. And if you had a super strong telescope, that one of those is what we call a binary star. Two stars that are orbiting each other around and around and around, like on Star Wars. But I just brought that up for no reason. But there supposedly is a binary star system in that pair of stars there, that if you had a super strong telescope, you'd be able to see it. And I never did find a super strong telescope to check that out. But I can see with my binoculars that there are two stars there. Okay, let's talk about the other side of the world. We're talking now about the southern sky. We're talking about the southern sky in the winter, because the southern sky in the winter is vastly different than the summer sky in the summer, because those particular constellations dip down below the horizon. So sometimes you can only see the constellations for a short period of time in the night, because they're so close to the horizon, dipping down underneath the horizon. So because we're in the northern hemisphere, we don't see these all the time, all right? In actual fact, there's some part of the sky that we can never see. It's the part that is on the opposite end of the world to the part that we can always see, and it's always below the horizon, and you'd have to travel to the southern hemisphere to do that. The only time I've done that is a few years ago, March break, we went to Costa Rica, which is, I believe, just below the equator, but we were always in a kind of a mountainy area that I could never see low enough to the horizon to see that part of the sky that I can never see. I would go out at night, I'd be like, oh, this really sucks, because I'm finally in the southern hemisphere and I could try to see this, and I wasn't able to see much of anything. So if you ever have the opportunity to go to the southern hemisphere, take the time to look at the sky at night. You will see constellations that you have never seen before. Yes.
You don't take a look at this one. It does.
Oh, that's a fun one.
But if you go down, you can see that there's also one.
So in other words, they're getting rid of the Earth so that you can see down towards where we wouldn't be able to see it. That's fun. Okay, let's talk about Orion, Rigel, and then Betelgeuse, I call it, Betelgeuse, some people say. And you know what, Rigel, do I care about Rigel? Which one's Rigel? Label Rigel. I think it's the other shoulder, but I'm really interested in this one. I'm not worried about Rigel. Let's go ahead and take a look. So, the Orion constellation, right, the great warrior Orion, is very big and pronounced in the southern sky. And right here, these are the three that you're looking for. Those three right there. They're all in a row and they're really tight. That is called Orion's belt. We're supposed to imagine Orion as being the warrior. He's got a sword way up over his head. These are his shoulders, all right? These are his hips maybe or something. There's his belt. His head's up here, his legs down here. I've often imagined that that's part of his sword, if he's wielding a sword, but I'm not worried about that. All I'm worried about there is that this is Orion, all right? This is Orion. And those three in the middle are Orion's belt, okay? The bright star here, all right? The bright star here is that Betelgeuse one, and I can't even begin to imagine how to spell it. I haven't even, could somebody spell that for me? B-E-T-E-L-G-E-U-S-E. That's the one, that's the red giant. And that's the one that's been dimming since October. Remember we talked about that? And it's big enough that it may go supernova. Is it going to go supernova in our lifetime? We don't know. I've read some things where they think yes and some things no. All right? If it were to go supernova, some scientists are saying it will outshine the moon. It will become brighter than the moon. All right? That would be wild. It'd be like having an extra big light in the sky for a while. We wouldn't be able to look at stars very much out down there because it would be so bright. that it would give off that light. Okay, so I want you to know how to locate Orion, and then that guy in the upper left-hand corner there is that particular one. The last one I want to find is the brightest star in the sky, and that is Sirius. Extend a line from Orion's belt to the south, and you will encounter the brightest star in the sky, Sirius, and then Canis Major. So, if we extend the belt, we get to there, and I don't know where the name Sirius comes from, but let's just go back. Let's make sure I can spell it. S-I-R-I-U-S. So that guy there is Sirius, all right? And I'm really not sure exactly where Canis, is it Canis Major? It's the big dog. That's what it stands for. Whoops, too far. Canis Major, I don't know exactly where you get the big dog from, but from what I saw online, it's like that. That doesn't look like a dog to me. Looks nothing like a dog. But that's Canis Major. Us? I'm questioning everything at this point. You got to help me. I-U-S, Major. All right, the big dog. It's a dog with a really long neck and very short legs. Giraffe. It's a giraffe dog. Okay. Those are the ones I'm going to ask you to be able to find and label on maps. All right? There are many others, obviously. If you have any of those apps out there, you know, obviously we've got even the zodiac signs, Leo, right? Obviously there's a lion in there somewhere, and all these other things. So there's many constellations. Can't possibly get you to learn them all, but these are you know, enough that now if you have never looked at the sky, you've got enough to maybe go out there and maybe have a look and see those patterns there. Okay? All right. You can see I'm asking you to do a little bit of reading and then answer a few questions for homework. I'm done my lesson. The note was essentially describing azimuth and altitude and that type of thing, and then how to find a few things. I am going to stop my recording right there.